All right, we got a little interesting thing on the bench tonight. This is that's an ECM. That's an ECM tester I built. It's gonna be part of the suite of tools I'm building. So, anyways, what's different about this? Kind of coincides with a project I'm doing, but what's different about this one is it's kind of focused towards generators. So we can test diesel, gasoline, nat gas, LP, air fuel solenoid. And what I mean by air fuel solenoid is Generac has a mega ejector. Generac uses this air fuel solenoid that runs the duty cycle off the O2 sensor and basically manipulates the the vent of the regulator. But and then we also have some other things like nat gas LP. We have something called a mega ejector on PSI, and basically it works. It's going to work with J1939. I'm going to get more to the interesting thing here. This is an ECM, and it coincides with another project, and it also does J1939 and Modbus. And that kind of coincides with this. This is a deep sea controller here running Modbus on my, this is my monitoring program here. And we get Modbus data based on, so basically we made a Modbus dongle or an adapter that will pull Modbus and J1939 diagnostics. So anyways, why would we test an ECM on the bench or an ICM on the bench? Well, we want to see if we have an engine issue. We want to see if the ECM is taking in all the inputs, all the sensor inputs, and doing what it needs to on that. Some of the things it does is something as simple as a coolant, an engine temperature sensor will affect injection on time for diesels, gasoline, and we want to be able to see how our injection on time or coil dwell or our timing, if a driver's dropped out and we're getting a misfire, it may be due to a driver is not turning on a coil. So we can pump in all the signals to wake the ECM up, but the hardest thing is you can't just put voltage to it. You got to make it think it's in the engine. And certain engines have gears, what we call reluctor wheels, that read engine timing. And it's like a code where it can know the position of the cam and the crankshaft. And basically, this is a code. Right now, this is a Ford. Oh, that's a 60 minus 2. Give me one sec. This is a Ford 36 minus 1 with one missing crank tooth. This would be a tooth on the crank, and a variable reluctor or a Hall effect, whatever type sensor will create a pulse that the ECM sees, and this little mark happening every 720 degrees lets it know where we are on our crank angle space. But then we also have a cam sensor. Now, when you scope, you start to know where your sensors line up, and usually on like a Ford Triton, around the 7th tooth after top dead center is when your cam pulses in. Your cam is just basically making it so you fire on intake or the exhaust. If you're not waste spark, we want to fire on the top dead center top dead center of compression and exhaust. So just want to show you here. So if I can change the speed of this by dragging my slider, and you can see if I slow it down, this widens up. I can drag the slider in, and I can bring that, so I can bring the speed up. And if you noticed, this is the coil, this isn't the cam pulse. I'm monitoring the crank. I'm not monitoring the cam right now with my scope, but I'm monitoring, this is the on time for cylinder number 1, or I don't know which one I'm probed into on the ECM. So you can imagine if this is the on time for the ignition coil, well, the faster the engine spins, the less time we have to to charge that coil. So that's going to decrease based on the RPM. Right now I'm telling it it's 6,000 RPMs. So let me slow it down to 1,800 RPMs, and you'll see we go out to the cursors. Now, what we're interested in is, and some of these are gearbox units. That's why I have such a wide RPM, because some will run higher than 1,800 RPMs because they're gear on the Generacs. So we're back down to there, and we got 1.2 milliseconds of injection dwell. Well, that's where we bring this sucker in. Well, let me change the ECM config. Let me bring it to standalone ignition, and then this is where the custom thing comes in. So some of these ECMs have governor control and starter relay out. So if we look at the injection panel now, you can see it's telling me coil 1 is firing. That's actually blinking, but it's firing so fast you really can't see it on the phone. And that's about 1.227 milliseconds of dwell time. So if I was probed in now, once I complete the PCB and get it in a nice box, it's just going to plug right in. You're going to see all these, depending on whatever you set up, you're going to see injectors firing. Now I got it wired in such a way where my coil is also driving an injector input, just to demonstrate. So if I change this to like a diesel, and I got my sensors going. Actually, let me go ECM config. Let me go gasoline, and I go my ejection panel. You can see I'm firing the injection there. And then one of the biggest things is comparing your O2 or on gasoline, comparing that against our dwell and our injection time. You're depending on the fuel mixture, depending on your O2 signals, we're going to, that's going to affect injection time based on our trims and stuff. So what we can do with our sensor, I can simulate the O2 sensor, and I can tell it my lean voltage, let's say 130, and my rich voltage is, let's say, 800-900 millivolts, and then we can do a cross frequency, let's say at 1 hertz. So it's going rich lean at 1 hertz intervals. Now you can see my O2 is pulsing here now, going up and down. I can also turn up my map. This is all going into the ECM, and then we come back into the injection panel here, and we look to see how the ECM is responding, for different sensors, like our baro, our map, and injection on time, our O2 and injection on time, and then we can, right now I'm monitoring right now, I'm mapping that to injection number 1, and the dwell times are the same because, like I said, I'm firing the ignition. I'm only tapped off of a coil. I don't have an engine with an ECM with an, actually I do, I have a diesel one that I'll do. So, and then it's also tied in to my monitoring system right here, the Gen Commander that I'm working on. Let me brighten this up. So that's the sensor sim, and then just to show you one more thing, if I go to the cam and the crank, so if you look at, let's say I needed to do a different code that wasn't in my preset. So let's say I want to make this third tooth go down. Well, if I click right in real time, I just made another gap. I can do another one. I can make a bunch of them and drop them out, and then I can bring them back, and we'll bring it back to normal. So that's where I am with this. At the dashboard, there's another dashboard just where you can kind of see some basic data. Our J1939, right now I'm not hooked up to J1939, and we do have OBD also. I can simulate it if I want, and you can see what it would look like. That's just so when I'm showing people the program. And then one more thing, we can look at the reluctor wheel. That's basically what it would look like. So that's H-scope putting in some work. That's an ECM. Generac has the older ECMs they're not making anymore, so I'm making a conversion and an adapter board to convert the old style to this newer style ECM. So I want to get, I want to see if I can, I'm making my own, and I'm also making an adapter, kind of seeing which route that would go. Just wanted to add one more thing, just so after slowing it down, you can see the oscillation. So if you really want to kind of get a visual, and then I do have a, there's one more, if I go to, if I'm on the gasoline, I might add it to this part here. So it'll light up like a fault, or I can short out the coils too, there. So you can see, I might bring this kind of feedback in to the actual, let me close this window down. I put that there so you can get the whole thing. So you get a kind of a bigger representation there. But you know, that's the actual ECM driving the coils, and you're seeing the control side, and you're seeing right here. This is measuring duty cycle, but we're also getting it when I go onto the standalone ignition page, and like I said, I can do the governor and all that, and go there, and we're getting perfect duty cycle there. And if we had a governor, we would see the control, and we can see the starter output. So, and you can see my width, 1.24 milliseconds, and we're right there. We're hitting 1.24, 1.25. So it's accurate. That's the biggest thing, see in the code here. So that's it.